flow control valves, in conjunction with the pressure relief valve, control the working speed of hydraulic drive units. This combination controls the flow rate, which is the decisive factor in setting working speed. Constant action pumps then supply a uniform flow rate. This means that a reduction of the cross-section alone would only lead to an undesirable increase in the speed of flow and, of course, to an increase in pressure upstream of the throttle point. But the flow rate remains unchanged. Here we see the working speed of the cylinder with the flow control valve open. If the restrictor causes an increase in resistance, the pressure rises prior to this. The pressure relief valve begins to open, which causes the fluid flow to be divided. One part flows to the cylinder, the other back to the reservoir. The slower flow rate now in effect reduces the working speed. Here we see yet another effect of the flow control valve. The greater the load, the slower the advance. A circuit that is not load dependent can be constructed with a flow control valve. A flow control valve consists of an adjustable restrictor and a regulating restrictor. The desired flow rate, and with it the desired piston speed, is set at the adjustable restrictor. As the load increases on the output side, the pressure there rises. This pressure acts together with a spring on the regulating restrictor, which then opens, compensating for the increased resistance. When this happens, the increased output pressure does not affect the pressure relief valve, which would result in an undesirable change in flow rate. Here's an example. Preliminary turning must not be load dependent, since an uneven advance would cause uneven machining. The two-way flow control valve provides a uniform advance speed. There are two ways to control the flow rate. Here we see control of oil supply. Restricting the flow in the supply line for advancing the piston causes the oil to heat up, but warm oil reduces the precision of piston motion in the cylinder. In some machines, this is not important, but this machining complex requires greatest precision, so that any rise in oil temperature is undesirable. So in a case like this, it's better to restrict the flow in the exhaust line. By this we mean that the flow of oil to the reservoir is restricted, because it doesn't matter if the oil heats up. At the same time, the cylinder piston is hydraulically clamped. But remember that the surface area ratio between the piston sides causes a transmission of pressure to take place. So the system must be suitable for the resulting high pressure.